Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, Mr. T here with another math tutorial. Today we're going to be talking about solving radical equations, so square root equations and also equations that have x's with fractional exponents, rational exponents. When solving those, our process will be similar to when we were solving equations recently with square roots. We will get the part of the expression or the equation that has the radical symbol by itself. We then need to undo the radical symbol. So to undo a radical, so if we had, for example, over here square root of x, if I square root of x, I get square root of x times square root of x, and using our properties of radicals, that gave us x. Or if we use our recent topic on fractional exponents, we could convert square root of x to a fractional exponent and use our exponent properties here of power to a power. And 2 over 2 is 1, and from our exponent properties, anything to the first power is x. So squaring a square root will erase a radical symbol. If this was some other root, like a third root, then we would cube both sides. If it was a fifth root, we would raise both sides to the fifth power, etc. So let's go, so let's finish. Now, key result, after we square both sides, we'll be rid of the radical symbol and we'll solve for x. And on these problems, there's a key issue that we have to deal with, is that our result, our solution, may be a false answer. It may not really solve the original problem. Those are called extraneous answers. And the only way to figure out extraneous answers is to plug our solutions back into our original problem and verify whether it works. If it doesn't work, then we discard that answer and it becomes what's called an extraneous answer. Our first problem will not have an extraneous answer, but later in the video we'll have a problem with an extraneous answer. So we have to here add 4 if we work our first sample problem. And then we need to get rid of that number, so that's multiplication. So the inverse of multiplying is to divide. So now we have our radical symbol by itself, so we're going to square both sides of the equation. 2 squared is 4, and on this side that undoes the radical symbol. And now we can solve for x, and we get x equals -1. Now before we circle that and declare that that is our answer, let's put it back into the original equation and check our work. Now -5 plus 1 is 4, and the square root of 4 is 2, so we have 2 times 2 minus 4. 2 times 2 is 4, and that's 0, so that checks out. So this is our solution. Now, a similar procedure works for equations that have fractional exponents. Remember, there's a relationship between fractional exponents and radical symbols. We reviewed that in my video on exponent properties or exponent rules. We want to get this by itself, so let's get to that step. So we're going to add 250 to both sides. And then I'm going to divide both sides by 2. And we get to the point where we have x to the 3/2 equals 125. Now, we want to raise this. Remember, when we raise something to an exponent, we are multiplying exponents. And we want to turn this into an exponent of 1. So if you multiply any fraction times its reciprocal, you get 1. So if we multiply, or raise, I should say, our fractional exponent term by the reciprocal exponent, Now I have to do the same thing to the other side of the equation. Here we would be multiplying our exponents using our exponent properties, and we get x to the first power, which is just x. And then we can use a calculator to determine that value if you're not able to do it by yourself. This 3 in the denominator means we're going to take the cube root of 125. The cube root of 125 is 5. And then if we square that for the numerator part, we're going to get 25. But many of you won't be able to do that in your head. Now just remember, when you use a fractional exponent on the calculator, put your exponent into a parentheses. And we get 25. Now let's verify that that's not extraneous, so let's put it back into the original equation. So 2 times, now we've got 25 raised to the 3/2 power. I'm just plugging into our original equation using the graphing calculator. Now we have minus 250, and we want to verify that that is 0, which it is. So that answer checks out, and that's our answer. So radical symbols or square root symbols, we're going to square both sides, and fractional exponents we're going to raise to the reciprocal power. Now this one is the same procedure as the first one, but when we solve it, the equation is going to end up being a quadratic equation. So if we square both sides here, like we did on the first example, I get x squared equals x plus 12. Now this is a quadratic equation, which we've spent a lot of time recently working on. We could solve that using factoring, completing the square, quadratic formula. This one looks like it will be easily factorable, so let's get it equal to 0. And now I need a pair of numbers that multiply to be negative 12 and add to be negative 1, so that's negative 4 and plus 3. And that gives me solutions of 4 and negative 3. Remember, when things are factored equal to 0, we just set each factor equal to 0 and solve. Now let's check these out. So if we go back to the original equation, I've got 4 equals the square root of 4 plus 12. So 4 equals the square root of 16, or 4 equals 4, and that checks out. So this one's good. Let's try the negative 3. Now we can see right here that this is not going to work out, because when you take the square root symbol, that means the principal square root, and that's always positive. So here we're going to get negative 3 equals positive 3, which is not true. So that's false. So this answer is extraneous, and we throw it away, and we have one solution. When we work problems like this, we could have both solutions check out, and we could have 2 solutions. We could have both solutions be extraneous and have no solution, or in this case, one of the 2 solutions was extraneous and we have one good solution. Now let's finish up with just one more example. Very similar to the last, except now on the left side, when we square this, we have a binomial. Now remember, that's not x squared minus 16. We have to turn that into x minus 4 times x minus 4. And on this side, we're going to get 2x. Now we can't solve this factor because this is not 0, so we've got to FOIL that out. If you FOIL that out and combine the like terms, we get this expression. Now we're going to subtract the 2x, and we get x squared minus 10x plus 16 equals 0. So this factors into x minus 8 and x minus 2. And we have solutions of 2, or possible solutions of 2 and 8. So let's check those out. If we put 2 into the original equation, 2 minus 4 equals the square root of 2 times 2. So we have negative here equaling a square root, so we know that's going to be a problem. So negative 2 does not equal 2. So this one is extraneous. Let's try the 8. 8 minus 4 equals the square root of 2 times 8. 4 equals square root of 16, which we know it does. So that one checks out. So we have one solution here, x equals 8. So good luck with solving these. Remember, we're going to square both sides. Our fractional exponents we're going to raise to their reciprocal, but the key thing here, make sure you check for those extraneous answers and don't miss problems on a quiz because you forgot to do that. And have a great day.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you